This is my configuration for Kong so that I can get to use the AI Semantic Cache plugin. How did I achieve this and what does this do? This is what we are going to see in this video. So if I go here to the project I developed and I've used in the other videos for the other different plugins that I've shown before that we can use with the Kong gateway, we can see here the readme AI Semantic Cache.md file where I have collected all the different examples that I want to use for this video. If we go here further down this file, we will see that now that I have everything configured, we can try these different queries to our service. And the first question is a very simple question, and that is we are going to ask via the Kong gateway the color of the sun. The exact question is, tell me the color of the sun. So let's see what happens when we now run this through the API gateway and get the response back. When we run this, we can see that it takes a while to get the response back, but then we get this response. And what our request says, our response to our request says, is that the color of the sun is white. However, it often appears yellow, orange, or red due to Earth's atmosphere scattering the light. Now, it is important that we memorize this answer, at least this part of the answer, because now I'll ask the same question in a different way in this other request. What color best describes the color of the sun? It is a question for the same information. We are requesting the same information, but under a different text, under a different semantics. So if we run this now, we will see the same response. We'll see the color of the sun is white. However, it often appears yellow, orange, or red due to Earth's atmosphere scattering the light. We get exactly the same response. If you are used to running questions against LLM models, like for example with ChatGPT or any other kind of AI, you know that we usually get not the same response back, but we get different responses back in a different text. Maybe the context is a bit different. Maybe it will give us a more in-depth response, maybe a simpler response, maybe with different words, with a different style, but we never really get the same response back. But here I am getting the same response back. This is because the AI prompt cache plugin from Kong allows us to store responses in a cache system. Now, the way this works is, and the benefit of it, is that when we are making different requests to our AI, we may want to make questions that are about the same topic, and further, we need the same content. And maybe it's not that handy every time to get the request to go to our LLM model to ask the same question again over and over and over. Perhaps it's better that if we can detect in the way we ask the question that the question has been asked before, that we can simply just grab our response from the service. And this is what we have here. And so the way this works is, when we ask a question to our LLM model, normally in a simple situation, we ask it, we get the response from our LLM model, and then we use that response and we show that response in our prompt. But with the AI Semantic Cache plugin, we can then make the request in a different way. And so the way it goes is, we ask a first question to our LLM model via the API gateway. That request first goes to our vector database. The data there is stored in vectors. Now, vectors is a way of storing data. We can say a lot about it, but what the most important thing is that we understand that we store their different entities, and those entities follow different patterns. And one thing is that we measure distances between the different text and questions that we put there. There's a whole theory behind it, but the idea is that we understand that these elements of data are stored in a different way. And the idea is that we search for similarities in them. There is a very good video about this from Redis. I will put that in the description if you want to understand more about vector databases. But the important for us here in this video is that we understand that the responses to our questions and the questions themselves are stored in that database. If we don't find a response to our question, then what the AI gateway is going to do, it's going to ask a request directly to the LLM. In this case, for this video, we are going to use Mistral, and we are going to ask Mistral questions. Then Mistral is going to give a response. That response comes in the form of embeddings, and then those embeddings will be vectorized to the Redis database. After doing that, we get the response back. That is our first response from Mistral. If we ask the same question with different texts or in a different way, the AI Semantic Cache plugin will be able to detect that it is the same question. And if it is the same question asked in a different way, the AI Semantic Cache plugin will then realize that, hey, this is the same question, so I already have the response in cache, so I will not ask the question to our LLM model. I am going to give the answer back from what I already have stored in my Redis vectorized database. And this is how simple it gets. But how we configure this plugin is what this video is about, and we are going to see that now. But I'm going to start from the point where the API gateway is already configured. We are going to use Konnect in this case. We would be able to use also the enterprise edition of the Kong gateway for local installations, but in this case, it's easier if we go directly through the Konnect website. To do that, we need to create data node planes and we need to configure our gateway. But to do that, I already had a video before in this channel. You can look at it right over here. There I explain how to first create our account in Konnect, how to create the gateway manager, how to create services and routes. We already have that now. So we are going just to focus our attention into how the plugin is configured and what sort of parameters it requires. So let's get into it right now over here. Via my Konnect account, I can see that I already have these two plugins configured. I am going to delete them now because we want to know how to create them and we want to see them being made. So we can delete them better this way. So delete, and then let's delete this one as well. Okay, so now we don't have any plugins configured in our gateway. Let's have a look first at how I have this configured. So in overview, we will find that I've got a serverless default gateway and a hybrid gateway. This hybrid gateway I created before, and here I already have a container running, and that container is an API gateway from Kong. We can go here to Docker PS, and we can see here that I've got a Redis stack server running, and I've got a Kong gateway version 3.9 running locally. These are two containers that I had to start so that we can get this plugin configured. Now, the second important step is to get the service, and this is the service that I have, my service, and then here I also have my route configured. We are going to configure this plugin per route, not per service, per route simply. And if we go here to, and if you go now to the project and see the README file and go all the way up, we will find that the first step is to configure the AI Proxy plugin. The AI Proxy plugin is important for us to be able to establish routes to Mistral. It doesn't matter much what we have here configured. It is important that we are able to have an AI proxy that recognizes that we are making requests to an LLM model. In this case, our large language model is Mistral, and that's why we have this here configured. Mistral Medium, Mistral, and we choose the format of OpenAPI, and then we choose the upstream URL, https api.mistral.ai/v1/chat/completions. But this is just for the AI proxy. What's important is that we have the semantics plugin to be able to communicate with the large language model from Mistral with embeddings, because we want the response in the form of embeddings, because those are the ones we are going to use to vectorize into the database in Redis. And that configuration is located over here. And we can see that we have a payload here for the AI Semantic Cache. For that, we need to hand in the Mistral API key via the header name and the header value. Then we need to say that in our model, the provider is Mistral, that the name of the model that we are using is Mistral embed, and that we provide an upstream URL of the embeddings endpoint. So instead of completions, we've got api.mistral.ai/v1/embeddings. Another important aspect is, of course, the vector database, because we are taking information from our large language model and vectorizing it and putting that into our database. And it is important for us to define what kind of vectors we want to use. Now, this part is where we need someone who is expert in developing vector databases, and we need to be able to choose what kind of strategy do we want to use, which in this case is Redis, because we are using a Redis database. We can define the distance metric, we can find the dimensions and the threshold, and then we need to define where we want to save the information that has been vectorized. In this case, the Euclidean metric is different than the cosine metric, and these differences have more to do with the way we measure distances between different entities which follow different parameters. The theory behind it can revolve around physical distances and can also revolve around angles. But in this case, it's not important that we know that for the configuration of the plugin. It's just important that we get an idea, just a small flavor of how this works, so that we understand that what we are configuring in this vector DB node of the JSON payload that we are sending to our AI Semantic Cache plugin. Now, the AI proxy has very little more to add. I've spoke about this AI proxy plugin in this video over here. Again, both videos, one that talks about how to get Konnect up and running, and the other one that talks about the AI proxy. I will put the links to them in the description of this video. So make sure to read that, and we could go further. And here at this point, we've got the command line that will run the Redis service. We need this, we need a Redis service container locally or anywhere we want, because we need to reach a Redis server. And it needs to be an open Redis service where we can simply run commands against it without authentication. So this container should be well protected if we are going to use a Redis stack server. This is one example of a Redis service that we can use. And here we get our Redis container running. As I've shown you before, we've got our container running, our Redis container, and our Kong API gateway also running. To run these commands, it is important that we get our variables correct. Our variables can be created like this. We can export them for our command line purpose, and we can then get the control plane ID. Let me show you how you do that. For the control plane ID, you simply just go here to the Konnect website. We go to our gateway, and then here we will get our gateway ID from this point. So then we can do export the gateway ID, the control plane ID, and then we put there our gateway ID. Here for the service ID, the same. We can just go here to the service, and then go here to gateway services, and then here, if we go to service, we can find here the ID, and the same thing goes for the route, which we can go here to the route, and then here we find my route, and here we can see the ID of the route, where we can then just simply do export route ID to that number. Now, for the Kong API key, it's also very easy. You can just go here to the My Hybrid Gateway, so whatever name you've given to your hybrid gateway, and then here we just need to press here and connect, and then admin API, and then manage access token. there will be an option here to simply generate a new token, and then you use the token that you generated here in this export. For the Mistral API key, we can just go to Mistral website. I've shown you before. You can just open here the website and go here, try the API, and we can go here to API keys, and then here we just create a new key and use that key for our tests. There are different options for the for Mistral AI, and we can use the API key over here. Finally, the Redis host. The way to get to the Redis host is simply by putting the IP, or if you have a domain name, if you are using a domain name, the domain name of the Redis host. In this case, for my local experiment, what I did is docker inspect and then put the 3 first digits of the container of Redis. So for example, 30B, and I've got here the IP address of my Redis container, 172.17.0.3, and then I use that in the Redis host environment variable. So we've got all of these 6 environment variables: the control plane ID, the service ID, the route ID, the Kong API key, the Mistral API key, and the Redis host. With these variables set into place in our command line, we can then run the commands that will create the plugins or configure our plugins in our API gateway via Konnect, simply by copying these scripts. So if I go over here and use these scripts, by the way, these scripts will connect directly to the European version of Konnect. Make sure to correct this for your region. So for example, if you are in the US, use US. If you are in the other regions, use the appropriate region for that. So here, if I just run curl and all of this, what I will now achieve is the creation of the AI Semantic Cache plugin in our gateway, in specifically our route. If I copy this and go here to the command line and paste this here, it has now created the plugin, but the plugin on its own will not work. We need the AI proxy. And for that, we can just go further up the README file, and then here we can just copy this. And then this will configure our AI proxy plugin. If we do that, then we've got our proxy plugin configured. And if we now go to Konnect, we should be able to see the plugin in the listing for our API gateway. So if we go here to the gateway manager, my hybrid gateway, and if I go here to plugins, then I will see the AI semantic cache and the AI proxy back in the way we configured it before. So now we can now make some tests, and the first test I'm going to make is tell me the color of the sun, just the way we started. Except that now I'm making this question for the first time via the plugins, only that I didn't change the vector database. So this means that we are probably still going to get the same response from the Redis service. So let's see what happens if I run this now. It takes a while, and now it says the color of the sun is white. However, the sun may appear yellow, orange, or red from Earth due to Earth's atmosphere scattering light. So we've got exactly the same response simply because I didn't remove any data from my Redis database running locally. But it did take a while to get there, and this probably has to do with initialization of these plugins. If I make now the question, what color best describes the color of the sun, we should now get a quicker response and exactly the same response. Further down, I have another question: is the sun white yellow? So it seems to be a different question, but essentially it's just a question that is trying to confirm what color the sun is. It looks slightly different, but semantically the response should be the same. And if we run this, we get the color of the sun is white, however the sun appears yellow. It's exactly the same response, with also that comment about atmosphere scattering light. Now we come to another question. What is the color of Mars? This is a different question, but Perhaps because the plugin isn't correctly configured in my case, or maybe we need to fine-tune the way it recognizes semantics, I come to an interesting response. It still says the color of the sun is white, however the sun appears yellow, orange, or red from Earth due to Earth's atmosphere scattering light. It's the same response. But why are we getting the same response? Well, perhaps the way we configured the plugin doesn't allow the AI Semantic plugin to detect that this question is not about the sun, that this question is about Mars. So this is where we start getting funny responses from the LLM model. If I go here further down, what is the color of a car? Now, Mars and Sun have in common that they are space bodies. They are different objects that are orbiting in a way. They have their own orbit, but they are part of the space realm. A car is different. Let's see if the large language model detects that the semantics here refer to a different kind of question. And if we do this, what is the color of a car? Then our LLM model will say, the color of a car can vary greatly as there are many different colors available for cars. Car colors include white, black, silver, and so on. And so we now get a different response that is accurate for the question that we made. And if you go and ask a question, is red rose colored red? We are basically asking a quite funny question, is a red rose colored red? And we should get a response from our LLM model that says, yes, a red rose is indeed colored red. The color of a red rose comes from pigments called anthocyanins, and it goes on to explain what that is. But now I want to make another question and see if this large language model combination with the AI Semantic Cache plugin can answer something different. Let's say, what is the color of Earth? Let's see what it responds. Now it does, let me try again. Now it responds something different. The color of a car can vary greatly as there are many different colors available for cars. Our question was clearly a question about asking what is the color of Earth. What this means is that perhaps our plugin, our AI Semantic Cache plugin, it's just not fine-tuned to the kind of questions we want to make to our large language model. So if we go to the configuration of our plugin, we will find this stuff again, VectorDB with the strategy, the distance metric, the dimensions, the threshold, and also the choice of what kind of database we want to use. Important here is that we know that the responses and the way we save those responses in the relation with those responses to the questions that we make to our large language model will influence the way the AI works for us in this case. So we want to make sure that we get this as fine-tuned as possible so that when we ask questions that require the same kind of response, that it knows exactly which response to get, and not something like this where we ask what is the color of the Earth and then it starts talking about cars. Just because we fed the car color question before in the model, and now the model thinks that the question has the same semantic as the question about the color of the Earth. Alright, so this is the way we configure the AI Semantic Cache plugin for Kong, and this is how we can make sure to use it with Kong Konnect. This plugin is very useful, as you have seen before, if it is fine-tuned, if it is correctly configured, and if we are interested in making several different queries to our large language model, and if we are sure that those questions can be cached, and if we are interested in caching those questions. It's only a question of looking at our current case and make sure that we make the right decision in using this plugin, because it doesn't always has to be a guarantee that it is a good plugin to use. So this was my presentation about the AI Semantic Cache plugin for the Kong API Gateway. We saw how to use it with Kong Konnect via the website of Konnect via our account. We were able to configure an API gateway, and in it we have configured the services, routes, and then in the end we installed the AI proxy to work together with the AI Semantic Cache proxy, allowing us to save responses and to make some kind of connections between the responses and the questions, although in our case some questions didn't really match the responses that we were getting. But we now know that that has something to do with the way we configure our vector database, which is the most important bit of the AI Semantic Cache plugin. And I want to emphasize this. That is the most important bit of this configuration. If we are configuring a vector database, we need to make sure that a vector database is able to store results in such a way that we minimize the errors of our analysis of data. If you like this video, make sure to leave a like to it. Make sure to subscribe to the channel to not miss out on coming videos. Make sure to pop in a comment about your video, about your experience, and if you have any questions there, I'm happy to help. And make sure to read the description for more information about not only the AI Semantic Cache plugin, but also other plugins that the API Gateway has to offer, or API gateways in general. And until the next video, be sure to stay tech, keep programming, be kind, and have a good one. Bye.
As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.